Number one, the following question examines the change in darts players' scores using two statistical tests. In the sport of darts, players take turns throwing darts at a board in order to score points. This the darts. A player's three-dart average refers to the mean score achieved when throwing three darts. Valia aimed to find out whether amateur dart players in her local area improve over a 12-month period. An increase in their three-dart average will indicate an improvement. She selected a random sample of 8 darts players and recorded their mean three-dart average from year 1. She then recorded their mean three-dart average from year 2. Valia's results were as follows. On this table, the data. Valia calculated the median quartiles and interquartile range for each year. The results are shown in table 2. A, B, C. Median A, upper quartile B, interquartile range C. Determine the values of A, B, and C. So we are going to, the first step, we are going to arrange this data in order for year 2. So year 2. From the smallest number to the greater. From the smallest to the greatest. Right. The smallest is 65.0, 68.0, 68.0. You can compare with data on the table, 70.1, 70.6, 72.0, 74.9, 92.9. And we're going to determine A. A is median according to the information in table 2. And median, there are 1, 2, 3, 4, 5, 6, 7, 8. It means median between here, 1, 2, 3, 4, 1, 2, 3, 4, here, the median or as the quartile 2. Okay. This is 71 plus 70.6 divided by 2, and it is 70.35. And after that, B, according to the table 2, that this is upper quartile. Upper quartile, it means this data. So we're going to find the median of this data 1, 2, 3, 4. Is here. This is the upper quartile. So 72.0 plus 74.9 divided by 2, it is 73.45. And next C, according to the table 2, this is interquartile range. Interquartile Interquartile range is upper quartile minus a lower quartile. So we're going to find the lower quartile. Upper quartile, this one, 73.45. So we need to determine first the lower quartile between this number 1, 2, 3, 4. So here, the lower quartile, 68 plus 68 divided by 2, 68, and 0. And the result is 5.45. Sorry. Question B. By comparing the results for both years summarized in Table 2, state one conclusion in context that Valium might be justified in making. Okay, so my opinion be some players. I'm going to writing here. Some players are showing improvement over the 12 month 12-month period as indicated by the increase sorry, by the increase in both median and upper quartile scores. Bentar. Question C. Valia then decided to analyze the data from Table 1 using a one-tailed pair t-test at the alpha or significance level 10%. 10% it means 0. Alpha 0.1. Okay. To determine whether the player's averages have increased. State an assumption about the differences in means that is necessary in order for the test to be valid. So C, uh, the individual meaning change in mean are independent one another. It means there is no correspond. Yeah. D, state the null and alternative hypothesis for the test. Find the p-value, state the conclusions of the test in context, justifying your answer. D. Okay, the null hypothesis and the alternative hypothesis. The null hypothesis is mu d equals 0, and the alternative hypothesis is mu d greater than 0. Mu d is representative the mean of difference from of the differences from the first table. You can evaluate the first table, the table 1. Okay. Second, I mean the second step. This is part 1. This is the first step. Okay, and the second step, we're going to find p-value. To find the p-value, first we need to find the difference on this table. This table. The table 1. Okay. Okay, difference. So the difference is this one. Justin, the difference 70.1 minus 68.1 is 2, 2.0, and this one is minus 0.2. This one minus 0.8, and this one 1.6. This one minus 1.8, and this one is 3.5, 1.4, and this one is 28.0. That one. And after that, I'm gonna find the next column, the I minus difference mean. Okay. Okay. And then difference mean is just now we already determined the mean. Wait, the mean not yet. I'm gonna find the mean first. Mean is mean of D. Sorry, but mean of D is, and this number plus this number plus this number and plus 28. It is 33.7. So mean of D, mean of D, or one. If you divide by 8, this number is 4.2125. This is, so after that, these numbers 68.1 minus, sorry, yeah, minus 2 minus 4.2125. Okay, and we got the result minus 2.2125. After that, 0.2 minus 4.2125, we got the result minus 4.4125. And then continue with the same method, 125, and this is minus 2.6125, and this one minus 6.0125, minus 0.7125, and minus 2.8125, and 23 minus 7875. So 28.0 minus 4.2125. Okay. The result is 123.7875. And after that, the I minus mean of D squared. So this number squared is 4.8945. After that, 19.4531. 25, 1203. 6.8, 258. This one 36.0756. 0.5089. This one 7.9023. And this one 566.6189. And if you calculate all this number, the result is 667.3984. This number. Next. So after that, we're going to determine the standard deviation. So the mean is 4.2125 and standard deviation, D standard deviation, wait, standard deviations of D or S, D, this one, square root 667.3984 divided by 8 minus 1. It is 9.77. One. And the next step, the T statistic. The statistic is the formula T equal mean of D divided standard deviation divided by square root N. N is 8. This is 4.2125 divided 9.77 divided by square root 8. So 4.2125 divided, this number I have calculated. The result is 1.22. So, and if degree of freedom, df, 8 minus 1 equals 7. So the p-value based on this information you can determine through calculator or through table. The p-value is 0.3133797 in calculator. In table 0.3134 or 33. Yeah, that is the p-value. And next, please state the conclusions of the test in context justifying your answer. Part 3. So p-value 0.3134 or 33 is greater than alpha. Alpha is 0.01. So it means we fail. The decision is we fail to reject the null hypothesis. And the conclusion there is no insufficient evidence at the alpha equals 0.01. Okay. Uh, 10%, it means not 0.01, 0.1, sorry. What is 0.1? 10% is 0.1. Yeah, 10%. Alpha 10%. And next for the conclusion, uh, to conclude that the players have increased from year 1 to year 2. Well, next question. Okay. Well, Falia was not sure the assumption made in part C was correct, and hence, though the result obtained from her peer t-test may not be valid. Following further research, Falia decided to use the Wilcoxon sign rank test, which does not require the assumptions she made in part C. For this test, the magnitudes of the differences between the year 2 and year 1 means are ranged from 1 to 8, with the ranks from the positive differences P, so P is the positive differences in this column, this table, and the ranks of the negative differences is N, separated in this column, this table. This partially is shown in the following table, which Valia constructs to perform the test. This and the question, determine the values of A, B, C, and D, and sigma n. For this test, the Wilcoxon sign rank test statistic is T. T is the smaller value from a choice of sigma p or sigma n. For the next series for G. Now we are going to find first T is F, A, B, C, D, and sigma n. So if we create the rank, we need to add one more column for the absolute difference. This one. So absolute difference of 2.0 is 2.0, and for minus becomes positive. So it becomes positive, becomes positive, becomes positive, becomes positive, uh, still 1.4 and 28. I'm going to fix this one first. Okay. Now we are going to rank this the absolute difference. The smallest number is this one. This is so what? According to this information, this is the second. And the third is this one. Okay. And after that, the fourth, 1.4. The fifth is 1.85. And the sixth is 2.0. One, 6. The seventh, 3.5. And the highest is this one, 8. 28. So according to the information that A equal 6, then B 5, C 7, and D equal 4. Writing here, A, A, A equals 6, B is 5, C is 7, and D is 4. Sigma n, sigma n, let me look, evaluate the table. Table n is 1 plus 2 plus b equal 5. It means 1 plus 2 plus 5. So sigma n equal 1 plus 2 plus 5. It is 8. Next, G. To the test, the Wilcoxon sign rank test statistic is T equal the smaller value from a choice of sigma P or sigma N. P is positive, N is negative. The null hypothesis is that the population's median for 3-dot average is the same in the both years. So the keyword is this one, the same. This is the null hypothesis. The population's median for 3-dot average is the same in both years, in year 1 and year 2. Valia chooses to carry out the test at the 5% level of significance, alpha 5%. From the statistical tables, she determines that the critical regions is T less than or equal 5. State the alternative hypothesis for this test. Alternative hypothesis is I'm gonna copy this one. This no hypothesis, the populations, medians. Okay, the populations median. I forgot for 3 that average for 3 that for 3 that average uh, is greater or is increase. I'm gonna using the term increase. Okay, increase from year 1 to year 2, or for both. From year 1 to year 2. From year 1 to year 2. That is the alternative hypothesis. Or we can state like this. Alternative hypothesis is mu d greater than 0. It means the population's median difference between year 1 and year 2 is greater than 0. And this is one. Second, write down the value of the test statistic T, determine the conclusion for the text in context. The statistic, the value of t, that is statistic, the value of t, we already calculate this is 8. And the third, the critical region, the critical region for the test at alpha or significance level 5% or 0.05 is t greater than 5 or if t equal 8 or 8 greater than 5. This one. Or t equal 8 greater than 5. This one. 8. Suggest briefly how Valia could assess the real reliability of her results for either test. Okay, this is my suggestion. The Valia could repeat Valia could repeat this test, the same test for the next year. Okay. Or the second opinion you can state this one, or the second, Valia would repeat the test with different sample for this year. So if Valia would like to repeat this test with the same sample, she has to repeat the test uh, on this year, but different sample. Uh, If Valia will if Valia will repeat the test with the different sample, she can repeat the test. She can do the test on the next year. Okay, that's if the same sample. If the same sample doing the test on the next year, if different sample, she can do the test on this year. So that's the difference. For the next year, uh, the with the same sample, better if I'm writing here, same sample, same sample, and if this year she has to find a different sample. Yeah. Number two. The following question explores a possible method of drawing phase portrait for nonlinear couple systems, taking a predator-prey model as a particular example. Gunner Green Wildlife Park contains a population of check geese, X measured in hundreds, so variable X meaning check geese, and population of gray foxes, Y, measured in hundreds. So Y, variable Y, represents of gray foxes. Research indicates that the population growth of both geese and foxes can be modeled by the following differential equations, in which t is measured in years. dx dt equal 2x minus xy half, and dy dt equal minus 3y plus xy. That's the function. Question A. At a specific time, there are 500 geese and 500 foxes, represented here by the coordinate 5, 5. At this time, determine the rate of change of geese and the rate of change of foxes. Okay, so this 5 represents of 500 geese and this 5 represents of 500 foxes. Right, on the space. uh, the coordinate point is 5, comma 5. Just now I uh, tell you that this 5 represents as the 500 of geese and this 5 is the represent of 500 foxes. So it means x equal 5 and y equal 5. Now we're going to substitute x and y into the x dt, right? So it means the x dt, x dt function is 2x minus xy half. It's 1. So if we substitute x and y into this equation, the x dt becomes 2 multiply 5 minus 5 multiply 5 half. And it is, you calculate, minus 2.5 because 10 minus 25. So this is minus 2.5. And just now, according to the information that this 5 is represent of 500. So we're going to multiply by 100. And it is minus 250 geese uh, per year or yearly. And the second is dy dt. Substitute 5,5 into this equation. So it's gonna dy dt is minus 3x plus xy. So it becomes minus 3 multiplied by 5, 5 times 5, and it is minus 15 plus 25 is 10. So multiply by 100. Okay. I'm going to scroll down first. And it is 1,000. 1,000 foxes yearly. Okay. Question B. There are two equilibrium points for the populations, A, 0, and B, P, key. So this is the first equilibrium, and this is the second equilibrium. Explain why A is an equilibrium point. Origin is the equilibrium point. Find the value of P and the value of Q. B part 1. Okay, at A 0, 0, it means x equals 0 and y equals 0. So the x dt it equal 2 times 0 minus 0 times 0 half, and the result is 0. As well, on dy dt, if you substitute 0 and 0, it's going to be minus 3 times 0 plus 0 times 0, and it is 0. So both rates of change are 0. This is 0 and this is 0. 0 at a 0, comma 0. So it is, I'm going to write that it is indeed an equilibrium point. Okay, so uh, the population cannot change. Populations of foxes and the populations of geese. Okay, two. I forgot the question. Two. Find value of P and Q. Okay. When the x dt is equal to 0, so it means 2x minus xy half equals 0, because dx dt equals to x minus xy half, like that. So we can calculate first, calculate all terms, calculate it 2. So it's going to be 4x minus xy equals 0. After that, factorize x, 4 minus y equals 0. So there are x equals 0 or 4 minus y equals 0. X equals 0, so y equal 4. So x equals 0 and y equal 4. When, here, when dy dt equals 0, it means minus 3y plus xy equals 0. I factorize y minus 3 plus x equals 0. So y equals 0, or minus 3 plus x equals 0. So x equals 3. So when dy dt equals 0, y equals 0, and x equals 3. So we are going to state that for the second equilibrium point, we get that x equal 3 and y equal 4. So x equal 3 and y equal 4. So therefore, the values of p and q, we can determine that p equal 3 and q equal 4. 1. xc is a function at points close to a origin 0, comma 0, we can ignore the xy terms so that the systems can be approximated by the x dt equals to x, dy dt equals to minus y. By solving these two differential equations, find an expression for x in terms of t, find an expression for y in terms of t as well. See, see part 1. The x dt equal 2x. So it means uh, 1 over x dx dt equals 2, or 1 over x dx equals 2 dt in integral 1 over x dx equal integral 2 dt. So integral 1 over x is ln x. Ln x equal 2t plus c. Yeah, that one. And this is part one. After that, exponentiating, exponent, exponentiating both sides. Okay, it's one is one. So if exponentiating this side, it's gonna be x. Okay, exponentiating it means becomes, if it becomes square or power 2, becomes x equal uh, e power 2t plus ca. I'm gonna using term ca, or e power 2t multiply e power ca, like that. Next, let a equal e power ca. So this equation becomes x equal a multiply e power 2t. Okay, it's one x, which a is constant. A constant because it is constant. Yeah. And next, second, 2, dy dt equal minus 3y. Okay. So it means 1 over y dy equal minus 3 dt, and integral dy integral minus 3 dt. So the integral of this expression is ln y equal minus 3t plus c. Okay, exponentiating becomes y e power minus 3t plus cb, or y equal minus e power minus 3t times e power cb, 1. And after that, let b equal e power cb. So the equation becomes y equal e power minus 3t plus cb, or it equal e power minus 3t times e power minus cb. Yeah. Uh, b equals 1. This is b. So this equation becomes b times e power minus 3t. Okay. This one x, and it is y. Next question. This one. Okay. So the x dt equals to x and the y dt equal minus 3y. Using your answer from part C, 1 and 2, show that the phase portrait trajectories close to A may be given by the equations x cubed y squared equal k, where k is a positive constant. The second, hence, sketch on a phase portrait one possible trajectory for small values of x and y. Right. D part one. Uh, on part C, we get x equal a e power to t. So, and y is b e power minus 3t. Okay. So we can, according to the information that we can uh, set this x becomes x cubed. If x is x cubed, so we need to create this term becomes a e power 2t as well cube like this, and it is a cube e 6 e power 6t because 3 times 2, and y equal b e power minus t if y squared as well this expression b e power minus 3t squared as well. So it's going to be b squared e power minus 6t. So if the expression x cubed y squared, it will becomes a cube e power 6t multiply b squared e power minus 6t, or it's going to be a cube b squared e power 6t multiply e power minus 6t, and it's going to be 1 because it is a cube b squared e power 0. So this is 1. A cube b squared. So x cubed y squared, it is a cube b squared. I'm going to scroll down first. And it is it it is a positive constant k. So k x cubed y squared is k. So k equal a cube b squared. So this is show that the phase portrait trajectories are described by the equations. I'm going to write it here better. This is this is shows that the phase of the phase portrait trajectories are described by the equation x cubed y squared equal k. So second, the second we are going to sketch x cubed y squared equal k, or y squared equal a over x cubed. Let's scroll down first. Okay. And y equals square root k over x cubed. And if you sketch this, okay, on this x-axis and y-axis, okay, recall that a coordinate point here, okay, here, a coordinate point. So it means the graph, this is the first equilibrium because there are two equilibrium. The first equilibrium is A 0, 0 origin, and the second equilibrium is B. B is 3, 4. So we're going to create a graph, okay, according to the first equilibrium. So near this equilibrium 0, 0, the trajectories will be curve. This curve x cubed y squared equal k, and will move outward from the origin. So it will be move outward to the positive area. This the positive area. And if you uh, if you if you create if you have assumption that x equals 0, so y will be undefined. If y equals 0, x will be undefined. So y-axis and x-axis are asymptotic for this graph. So the graph will be like this. Asymptote to uh, asymptote to y-axis and x-axis. Alright. And outward from the origin, from the equilibrium, the first from equilibrium. That's according to the eigenvector rules, if you will sketch. Okay, next, part E. The move. Now consider points x, y close to B on the phase plane. Okay, B is 3, 4. These coordinates can be rewritten as x equal p plus x and y equal q plus y, where p and q are the values from part B2. So according to our result, that on part B, on part B2, that uh, P equal 3 and Q equal 4. By substituting into the original model, show that for the small values of x and y equal x is x equal 3y minus 3y half. Move to part E. So E uh, on part B, we gain that P equal 3 and Q equal 4. So it means x equal p plus x, and it is 3 plus x, while y is q plus y, and it is 4 plus y. Now substitute uh, x equal 3 plus x and y equal 4 plus y into dy dt, into dy, sorry, dx dt first, dx dt. X dt is 2x minus x y half. So we're going to substitute 3 plus x and 4 plus y. It's going to be 2 multiply 3 plus x minus 3 plus x, 4 plus y divided by 2. And 6 plus 2x, 1 half. And if you calculate, this is 12 plus 4x plus 3y plus xy, 2x minus 6 minus 2x minus 3 half y minus x y half, 0, 0. So dx dt equal minus 3 half y minus x y half. One. Down, and for small values, of x and y, so the term in x, the term in this one xy, the term in xy, we can be ignored because the small values. So it means x, we can state that x equal minus 3y half plus the small number. So x parallel with or equivalent with minus 3y half, this one. And after that, substitute x equal 3 plus x and y equal 4 plus y into dy dt. Okay, this one, dy dt. dy dt is minus 3y plus xy. This is going to be minus 3, 4 plus y plus 4 plus y multiply 3 plus x. Yeah, same. This is 3 plus x, this is 4 plus y. And it's going to be minus 12 minus 3y plus 12 plus 3y plus 4x plus xy. 0, 0. So dy dt is 4x plus xy. So for small x and y, same with the previous one. For small x and y, we can ignore the x times y. Okay, so it means dy dt we can state as 4x plus the small number. So it's going to be 4x dy dt equivalent with 4x 1. This is right. And after that, oh, the next question. Sorry, the next question. Next question. Given that this matrix xy equal m xy, so this is the vector x and vector y, and where m is a square matrix, write down m. So we're gonna find m. M is the square matrix, or the square matrix, it means matrix 2 times 2, 2 columns and 2 rows. Okay. F, given that the vector is 1, equal uh, m x y. And as well, according to the information that x equal minus 3y half and y equal 4x. This information we get from the previous solutions, part E. Right, so back into this equation, it means x vector y equal m. Okay, m is can m is a b c d, while this one is x y. So we want to find m. Uh, this matrix, how much e, how much b, how much c, how much d. And if we calculate this ax plus by, okay, it equals minus 3y half, this one, because it's x. Okay, this is x. So if the result is minus 3y half, and it means it's supposed to be, this is 0. So 0 times x plus by equal minus 3y half. Why this is 0? Because the result is minus 3y half. There is no variable x. Okay, so it means a must be 0. So if a is the condition like this, it means we can writing that b equal this one y divided by y, b equal minus 3 half, this one. Now we're going to find a. Next, if you calculate this, c times x is cx and d times y is dy equal 4x. If you calculate this, the assumption is y should be 0 because there is no y variable here. So it means d must be 0, 0 times y. And this is still cx equal 4x plus here. So cx equal 4x and x is equal by x, so c equal 4. So m, we can determine m is a, b, c, d, or m equal a equal 0 and b minus 3 half and c 4 and d 0. So this is m. This is the matrix m. Okay, next question. G. By finding the eigenvalues of m, describe the path of the trajectories close to point B. Okay. Part G. Right. To find the eigenvalues of matrix M, we are going to start with the determinant of matrix M minus lambda times identity matrix. Okay, we have to state this one, and we're gonna find M. So firstly, we need to find M minus lambda I. M minus lambda I. M is 0 minus 2 minus 3 half 4 0 minus lambda 1 0 0 1 identity matrix. So this is 0, 4, minus 3 half, 0, minus lambda, 0, 0, lambda, because lambda times 1 times 1. And it's going to be, if minus, so becomes minus 0 minus lambda, minus 3 half minus 0 is minus 3 half, 4 minus 0 is 4, and 0 minus lambda is minus lambda. And the determinant of this matrix M minus lambda I is uh, minus lambda times minus lambda, lambda squared minus 3 half multiply 4. And it is 4 lambda squared plus 6 here. So this is the determinant m minus lambda I is 1. Lambda squared I. Now we are going to determine lambda, and after that we're going to find the eigenvalues of m. So this is equal to 0. So lambda squared equal minus 6, or lambda equal square root plus minus minus 6, or plus minus square root 6 minus 1, or plus minus square root 6 I, that one. And with calculator we can determine square root 6. The square root 6 is plus minus 2.45 I. So there are two values of lambda. Lambda equal 2.45 I, and lambda equal minus 2.45 I. So these are the eigenvalues. So the path of trajectories, the path of trajectories the path of trajectories, okay, is ellipse. Okay, is ellipse. Later on the next the next question we're going to sketch. Next question. This one. H. And sketch a complete set of trajectories in the phase plane for the original model, clearly indicating both equilibrium points. All right, here. H. On part B, I'm going to write on part B, you may evaluate on upwards our solution, our answer, that coordinate point A on part B, coordinate point A is 0, 0. This is origin. So if you create a diagram like this, like this, x-axis, and this is y-axis, right? So the first equilibrium is A here, 0.0. According to part B, you can evaluate again part B. And the second equilibrium, B, okay, on part B is uh, the phase plane will have two equilibrium. Okay, so A 0, and B, the second equilibrium is 3,4. This one. Next. Now we are going to sketch the graph. Nearby, according to eigenvalues rules to sketch the graph, nearby the first equilibrium point, called at point A, 0, the trajectories will be curves. The curve of around here is x cubed y squared equal k, or y equals square root k over x cubed. So now I have derived this. So it means how we sketch these equations will move outward from the origin from 0, 0 as both x increase and y increase as well. So it's going to be, uh, sorry, decrease means okay, like this. And direction will be okay, like this. Okay. Next, how about we are going to sketch the trajectories around the second equilibrium 3,4 around here 3,4. Okay, this is equilibrium, the second equilibrium. Near point B, near the equilibrium B, the trajectories will be ecliptical. Why? Because the purely imaginary eigenvalues and oscillating around the point, around this equilibrium. It will be oscillating. So the trajectories is like this, ellipse. And the direction like this. Okay. Next question, I. In this wildlife park, at a specific time, there are 500 geese and 500 great foxes. Based on the values found in part A, the park wildlife keeper is worried and assumes that the geese will quickly die out. Suggest whether this assumption is supported by the model. Justify your answer. Right here. I. I'm going to writing my opinion about this question, about these questions that given x equal 5 and y equal 5. X equal 5, it means 500 geese. Okay. And y equal 5, it means 500 foxes. Okay. So x equal 5 and y equal 5 will not lead the extinction the extinctions of geese. Okay. Based on this information, Based on this information, first, uh, despite the negative initial rate of change of the geese here, okay, the geese, which is the x, the t is minus 2.5 as my explanations on the previous number. So the trajectory is part of a closed loop around the equilibrium point B, which is 3, comma 4, 1. And the second, so this is 1, and the second, this suggests, this explanation suggests that geese and fox population will oscillate around the equilibrium. Equilibrium point. Okay. As I sketch on the graph, this, yeah. Okay, from point rather than the geese dying out as the keeper fears. Hmm. So we can state that. So we can state that the park keeper, is incorrect. Incorrect.